In this video, we are going to cover how to display quantitative data. And we're going to have three primary ways in which we're going to do that. We're going to have our histograms, our stem and leaf plots, and dot plots. The histograms will be the most important. They're the ones that you're going to see the most in practice. Um, However, stem and leaf plots and dot plots can be really useful if we're looking at small data sets. Um, but histograms, on the other hand, will be the better option for looking at large data sets. Right. So, what is a histogram? Well, basically, is what we're going to do is we're going to break our data into groups. Okay. And those groups are going to be based on intervals on the number line. Okay. So essentially, we'll collect all of our numbers, say between 0 and 10, okay, and we'll count how many we have in between 0 and 10. Okay. And let's say we have five numbers between 0 and 10. Then our first histogram bar will be 5 units high. And then let's say we move to the next interval. And so we're looking for numbers between 10 and 20. And so we'll count how many numbers in our data set are between 10 and 20. And we'll create another bar. Okay, and its height is going to be based on how many things were between 10 and 20. And we keep doing this procedure until we end up with a histogram, which is going to look a lot like what we call a bar graph. Okay. And the reason it's going to look a lot like that is this graph will have bars. Well, let's go ahead and take a look here at an example. So we're going to use this data set right here in order to create a histogram. And so is what this data set is it's the number of hours that classmates spent playing video games on weekends. So this is just a made up data set here. Okay. And so in step one, we need to decide the class width, okay, or bin width. You can call it either one, class width or bin width. And, our data here only goes from about 0 hours to 23.75 hours. Okay. So you could imagine if we were to look at our number line, um, one reasonable way to do this might just be to look at numbers from 0 to 25. Like that would be maybe what we put on our x-axis of our histogram. Okay. Now that 0 to 25, how do we want to break it up? Do we want to count by tens? Do we want to count by fives, by ones? And you actually have to experiment with it a little bit to see which option looks best. Okay, and we'll take a look at how that would look for this problem in a little bit. Okay. But the one that I found most reasonable was a class width of 5 here. And so we have one class from 0 to 5, okay, which that interval there includes 0 but excludes 5. So that first interval from 0 to 5, 4.99999 would be in it, but 5 is not. 5 will be in the second bin or second class from 5 to 10. Okay. And so that second class includes the number 5, but excludes the number 10. Okay. And the way I know that is with this notation that we have here. The bracket means that the number is included, while the parenthesis means that that number is excluded. Okay. And so the convention that we will use in most cases is that the left endpoint is included, the right is excluded. You will occasionally see people maybe excluding the first and including the right, or maybe doing something a little bit different than that. Okay. But this is a good way of going about it. So is what I want to do with each one of these bins here. You saw the next slide there for a second, but from 0 to 5, I want to count how many numbers in our data set are from 0 to 5, but again, excluding the number 5. Okay. And so I see a 0 and a 2.25. So there are two numbers in this first bin. Okay. And you can see over here on the right, it says frequency 2 for the class or bin of 0 to 5. Okay. And now we'll want to do this for 5 to 10. We want to find what numbers are 5 and larger, but less than 10. And if we come over here, you'll see 9.95 in the first column of the data set. You'll see 5.5 in the first column of the data set. And then in the third column, you'll see 7.5. And those are the only three numbers that are in that second bin. Okay. So you'd come over to this frequency table and you'd write in a 3 for 5 to 10. Right. But something kind of interesting does happen here. You can see that there are actually one, two, I think two tens in this data set. And again, we did not put the tens into this second bin. They go into the third because we have that hard bracket for that third bin saying 10 goes into this bin, the third one. And so we could try to count those. I'm afraid I'll miss one here, but let's give it a try. So 10 to 15. So let's see, where's our first one from 10 to 15? I think 10 is actually the first number in the second column. And then we have the 11. The 15 will be excluded. That'll go into the fourth bin. And then we have another 10. So that goes in this third bin as well. So we have three numbers so far. If we go on to the fourth column, I don't see anything in there from 10 to 15. And then next we have a 12.75. So now we have four numbers between 10 and 15. And I think that's the last one. So if we come over here, yeah, we can see the frequency says 4 for that interval from 10 to 15. So now the question is, what should we do from here? Well, those frequencies are how large the bars are going to be. Okay. And how wide they're going to be? Well, they're going to be as wide as the intervals for our classes. So all of our bins are going to have a width of 5. Okay. So if we come over here, we'll be able to see it. There it is. You can see the first bar stretches from 0 to 5 and has a height of 2. The next one has a height of 3 and stretches from 5 to 10. So you can see how this corresponds to this little table we had over here. And you also can see that for this class, this data seems to be skewed a little bit. It seems that many of the students are spending, 10 or more hours on the weekend playing video games. Now, this graph over here on that we're looking at is not the only way that we can make a histogram. So we could put the percentage instead on the y-axis instead of the number of students. Okay? And I want to point out number of students is the frequency. Okay? So we could put what we call the relative frequency as well. Okay? But relative frequency or percentage would be the other two options. And so if you want to compute the relative frequencies, you just need to count up how many pieces of data you have. And so we had 25 different pieces of data. So the first class contained 2 of the 25 pieces of data. Okay? And so that gives us a relative frequency of 0.08. Okay? The next bin contained 3 of 25 pieces of data. And so that bin has a relative frequency of 0.12, and so on. Okay? And then you can see to convert those to percentages, if we wanted to, we could just multiply by 100. Okay? And so when we go to look at our next page, is what we're going to see is both of these histograms look identical other than the y-axis. Okay? On one side, we have our percentage. On the other side, we have our relative frequency. But again, the only difference on the y-axis is one of the axes is really multiplied by 100. But these both give us the same information. We can again see that many of these students, again, are spending 10 or more hours playing video games on the weekend. And so one of the things I want to do here in a little bit is show you how we can create these sort of graphics on our calculator and how we can create them in Excel. All right, but before we do that, I want to go over how we can choose the correct class width. Okay. So you can see here, if there are too few bins, it's hard to tell how the data is distributed. Okay. That's not clear until we actually see a picture, which we will in a moment. And if there are too many bins, the histogram will fail to be a good summary of the data. Okay. So the idea is with a histogram is we want it to be a summary of the data. We don't want it to actually be the entire data set. Otherwise, we might as well just be looking at the data instead of the graphic. So here is me experimenting with different bin sizes. So the one in the upper left is a bin size of, let's see here, it looks like to me that's maybe a bin size of 12. Yeah, I think that's 0 to 12. So the first bin contains all of the students who spent between 0 and 12 hours playing video games. The second bin contains those who spent 12 or more. Okay. But is what you kind of looking at that first histogram, it doesn't really show us where the data lies. The bins are too wide. Okay. So we just know all we can really see here is there are more people in that second bin, but they could be anywhere in that second bin. It's really large. Okay. Um, as opposed to the one in the bottom right, where if you look at most of those bars, most of them have a height of 1. Okay. And that's because I chose too small of a class width. And so I have too many bins, meaning that what we're looking at here is almost the raw data. Okay. Very few of those bins, again, contain more than one thing. Okay. And then if you look at 5 bins and 12 bins, okay, you can see that these both, I think, do a pretty good job of summarizing the data without um, giving us too much of the data. Okay. Again, we want it to be a summary. Okay. We don't want to actually see each individual piece of data. Okay. But I think I prefer the one in the upper right with 5 bins. But again, the 12 bins looks pretty good too. It does show us um, how things are distributed, and specifically how hours spent playing video games is distributed without showing us each individual piece of data. Right. Now, when we describe these histograms, we like to describe them as symmetric or left or right skewed. There's a couple other words we use, but these are very common words to help us describe a distribution or histogram. And so, if I were to just put these up here, you can now see that the upper left one we're calling left skewed. The upper right one we're calling right skewed. And we do that because the tail of the distribution is to the left for skewed left. And the tail is off to the right for the one that is skewed right. Symmetric, on the other hand, means that we could fold it right down the middle and that both sides look exactly like each other. Okay. Now, a lot of times we're not going to have things that are perfectly symmetric. So we'll say roughly symmetric or approximately symmetric. Um, but yeah, this one here is actually perfectly symmetric. Now, when it comes to talking about symmetry versus skewness, we're talking about the shape in some way. But another way we can talk about the shape is how many peaks the distribution has. So if it has one peak, it's unimodal. If it has 2 peaks, it's bimodal. And if it has more than that, we'll usually just call it multimodal. Okay? But a lot of what we're going to be working with this quarter will be data sets that are symmetric and unimodal. And we don't know why yet, but we'll find out later on this quarter. And then the last thing when it comes to Histograms is we can have outliers. Okay. And so this is just a piece of data that is really far from the rest of the data. Okay. And there are going to be some ways we can check um, to get an idea on whether something is an outlier or not. But there is no perfect way to do this. Okay. In fact, to truly identify an outlier, a lot of times you need to be an expert in wherever that data came from. Okay. So if it has to do, um, something with, let's say, heart disease. Okay. Well, to identify whether somebody is an outlier or not, you probably need to know quite a bit about heart disease. Okay. Right. Now, we're going to look at stem plots and dot plots here in a minute, which will be really good for plotting smaller data sets. So I'm going to have us do that. But as soon as we're done with that, I'm going to have us look at how we can make some of these graphics, or specifically how we can make these histograms that we've been working on the calculator and again in an Excel. Okay. But let's real quickly go through these other two options. So if we happen to have a small data set, we use a stem plot or a dot plot. Okay. All right. So for a stem plot, this is also sometimes called a stem and leaf plot. Okay. So the stem versus the leaf. Well, the leaf is always going to contain the very last digit, while the stem will contain all the digits before that. Okay. Um, and let's just go ahead and take a look at what stem and leaf plot looks like. Okay. So here's some data set of pre-calculus first exam scores. And if we were to turn this into a stem and leaf, is what you do first is note how many digits are in your number. So ours are 2. Okay. So we'll always be putting the last digit, which is the second one, in the leaf column. But in the first, we'll be putting in, or in the stem column, we're going to put in the other digits. Okay. Now, when I say other digits, there's only one other digit. We have the first and second. Okay. So in this case, if we're looking at, say, that 33, the very first thing in our data set, the 3 for the 30 is what goes in the stem here. Okay, so basically, this first row is for 30s. The second row is going to be for 40s. The third row for 50s. The next one for 60s, and so on. Okay, and so the number 33, again, we have the 3 for the stem, the 3 for the leaf. But when we go into the 40s, you may notice, well, there's 3 numbers in the 40s, a 42, a 49, and a 49. Okay. So in the leaf section, we're only writing in that last digit, the 2, the 9, and the 9 for those numbers. It's the stem that's 4 for all of them. Okay. Right. But also, you could imagine that this does give us a pretty good idea on how the data is distributed. And in fact, it actually looks a lot like a histogram. Okay. If I were to copy this, and I'm going to exit here and just go into OneNote real quick. Okay. So here is our stem and leaf plot. And I said it looks like a histogram. And I think some of you are wondering, how on earth does this look like a histogram? Well, if I just turn it to the left here, this is a histogram now, and it's grouped by tens, right? This first bin, let me highlight it. This bin right here is for the numbers in the 30s. So from 30 up to 39.999. Okay. As soon as we hit 40s, we go into the next bin. Okay. So this is, again, a really good way of displaying the data quickly when it's a small data set. We would never want to do this if it were a really large data set, but kind of looking at this, it looks kind of bimodal to me. I kind of see these 2 peaks here. Okay. And it also looks like maybe there's a little bit of skewness off here to the left, but again, this is a small data set. We don't necessarily need to use those words here for this one. All right. So let me pull that back up. Okay. So the other type of plot is a dot plot, and it is as simple as just stacking dots. Okay. So for instance here, when I go to make this, well, I put a dot above 5 for my first number that's a 5. I'll put in another dot for 5.5. Then you can see that 6 repeats 3 times, so I have 3 dots stacked. Okay. So when you do make a dot plot, you are putting a dot for every single piece of data. So once again, if this is a large data set, it's going to be a little bit overwhelming to make, okay, because it's going to have a lot of dots in it. Right. So maybe again, a histogram might be better if we have a lot of data, but for a small data set, again, this is really convenient. It both summarizes the data and gives us all the data simultaneously. All right. So I want us to start off with the calculator. Let me see if I can zoom us in here a little bit on this data set. And we're going to try to plug this into our Texas Instrument calculators. Okay. So let me go ahead and open it up. Okay. So the first thing that I want you to do here is I want you to hit Stat, and then I want you to hit Enter for Edit. Okay. And if you have any data in here already, you can say arrow up onto list 2, L2. Do not hit delete, hit clear. And even though it doesn't appear that it's done anything, if you arrow down or back down, you'll see that it did clear that list out. If you hit delete, it will actually delete list 2 altogether, and you only have a list 1, a list 3, a list 4, and so on. Yep. Similarly, I'm going to go over here, arrow left, and then arrow up to L1 and hit clear, and then arrow back down. And now is what I want us to do is start typing this data in. After each number you type in, you're going to hit enter. I'm going to try to split my screen here a little bit so that I can see the data as we're typing this in. Let's see. Here we go. Okay. So we have that 9.95, enter, 10, enter, so on here. I almost always double check everything I type in on these calculators because it's so easy to make a typo. I probably will not double check on this because we've already seen the histogram for this twice. So we'll know pretty quickly if we've made a typo, if it looks different than what we had. Okay, so 3 rows done. I just have 2 more to go. All right, there we go. We got it all typed in. Okay. And so let me make my calculator a little bit bigger here. So once you get all that data typed in, I want you to go ahead and hit second and then y equals. And this is for that little thing in blue here on my calculator that says stat plot. So I hit second and now I'm going to select y equals. And you can see all my plots are off. So I need to go and turn one of these on. So I'm going to hit enter on the first one here. And I'm going to hit enter on. Okay. And then you can see down here for type, there's a few different options. I'm looking for the histogram one here. So right there, so I can hit enter there. Okay. And then down here for my list, it just wants to know where did I put my data. Okay. And so if we actually were looking at that as we were typing it in, we were typing it into L1 or list one. So I want to hit second and then the number one for list one. And you can actually see there's a little L1 above the number one, a little L2 above the number two, L3 above the number three, and so on. So if I wanted list three, I could hit second and then the number three, and then L3 would have popped up. All right, and then from here, okay. Right now this says FREQ1. Let's see what this does here. Okay. So we are going to eventually want to hit graph here, okay. But I want us to go into window so that we can adjust some things. So you might remember we were looking at X values from 0 to 25. So my X min I'm going to put in as 0. My X max is 25. Now, our bin width, we were counting by fives, right? So I'm going to count by fives here on the x-axis. Okay. And I don't think any of the frequencies went above 10. So on my y-axis, I'm just going to go from 0 to 10. And we'll just count by ones. Right. And so now that we have that all set up here, okay, I do want to point out we will never mess with X-res here or delta X or trace step. It's everything from Y scale and up. That YSCL means we're counting by ones in the Y direction, and the XSCL means we're counting by fives in the X direction. So we should be able to go ahead and hit graph here now and see our histogram. Okay. Now you can see I already have some other things in here that you probably don't have. If you are seeing some other graphics in here, you might have something in your Y equals, and you can go ahead and clear those out. Okay. And then just go right back to graph. There we go. So yeah, here's our histogram. It looks a lot like what we had. One of the downsides to this histogram is there are no labels. Okay. There are tick marks, but there are no labels. But if you want to, you can actually hit this trace button and it'll tell you what bin you're on. Okay. And they're telling me that this includes numbers starting at 0 but less than 5, and it says n equals 2, meaning there are 2 numbers in this bin. Okay. And if I right arrow, I'll go on to the next bin, which includes numbers starting at 5 but less than 10, and it says n equals 3, so there are 3 things in that bin. So this is one nice way to do this. You might find it even easier to do in Excel because then you don't have to adjust the axes. And so I'm going to show you how to do that here real quick too. So I have Excel here. And I'm going to just start typing this data right here into, what is this, cell A1. Okay, so the first row, column A. So we have, I'm going to write hours. I'm going to actually give it a label. But we'll put in 9.95 as our first number, and 10 and 2.25. And I'm going to say this again. I'm not going to be super careful here and double check because we've seen the histogram now 3 times. So we'll know if we make a mistake here, or if we do make a significant one, at least we'll know it. Okay. But I almost always double check this kind of stuff. All right, so I have the data typed in here now. So I'm going to make my Excel document a little bit bigger. Maybe I'll even zoom in a little bit. So it's what we want to do is we want to highlight this column here with our data. We want to go over to insert, And over here, you see a bunch of things that look like statistics charts. If you hover over one of them, I believe it will actually say insert statistics chart. And so this is the one we need for the histograms right here. I'm going to go ahead and click that. And I'm going to hit this very first histogram here. And I can put up here that, we were looking at hours spent playing video games if I want to edit this. And if there's more that you want to add to this, you can actually hit this add chart element here in the upper left and see what other kind of options you have. So, like, for instance, I could say I could include some axes titles. So, like, for say the vertical one, I just hit vertical. I can come over here now and I can type in that this was a frequency. And I'm going to go back to that add element chart so we can see what else is in here. Okay. Um, we also have the data labels that we can add in here. So we can say essentially how many things are in each one of these bins. So I like to actually have these outside like this. There we go. So now we know how many things are in each one of these bins. You can see the bins are broken up different though than how we broke up ours. So the first bin includes the numbers from 0 to 8.3, but it also includes both the 0 and the 8.3. Versus the second bin excludes 8.3, but it'll include everything that's bigger than it up to 16.6, but 16.6 is included. And then similarly, the last one, 16.6 is excluded, but anything bigger than it that is also less than or equal to 24.9 will fall in that third bin. Yeah. All right. But I think if we also just click down here, or actually, I'm going to hit add chart element one more time. I want to see if there's a way in which we can adjust our bins here. So I'm going to hit more axis options. And then I do see it says bins here. So I could hit bin width and I could type in 5. Okay. And there it is. Okay. And you may note this does look a little bit different than our histogram, but notice that their second histogram bar again includes the number 10 while ours excluded it. So there's nothing wrong with this Excel one here, and there's nothing wrong with the one in the PowerPoint. It's just that they were using a different they were choosing their bins in a slightly different way. Right. And so this right here wraps up how we're going to plot our quantitative data.